First of all, welcome everyone, and thanks for joining today's PTC Talks, where we are super excited by having Andreas Pabbinger, who is the global head of automotive in the CODEBEAMER team at PTC, and he will give us an inspiring session on adapting to the evolution of the automotive industry. But first, a very quick introduction about myself, and my name is Torbjörn Peterson, and I'm the Alliance Manager for PTC in the Nordics, and we are running all these webinars at the same time every week, where we invite customers and partners for some inspiration on digital transformation to see what is possible and how to make things happen. And all the past webinars have also been recorded and are to be found on the registration site. The agenda for today is first a very quick overview of PTC by my colleague Carl from the Customer Success team, and then Andreas will start by introducing himself, touch base on a few challenges, how to address these, and then explain some of the business outcomes. And at the end, we're also having a Q&A session, so please keep your questions to the end or put them in the chat, and we will pick them up later. So over to you, Carl.
Thank you, Torbjörn. So PTC is an international software company with headquarters based in Boston. We are developing software mainly for manufacturing companies since 1985. We offer tools for the digital transformations such as CAD for design, PLM for managing data, IoT to connect products or manufacturing operations, and augmented reality to visualize and interact with the digital thread. To you, Andreas.
Great. Thanks, Torben. Thanks, Carl. Thanks for the invite. Good afternoon to everybody. It's a pleasure being with you today. And as indicated by Torben, we have an interesting agenda today. Yes, it's a big subject, adapting to the evolution of the automotive industry. I need to tell you guys, for 30 minutes, it's a lot of things we want to talk about. I will speak probably fast. And at the end, as indicated, we have also hopefully time for a quick Q&A session. So let's go into our webinar today. Yeah. Automotive industry trends. I'm pretty confident that most of you have heard about that. Electrified, autonomous, shared, connected, over-the-air updates. I still want to refresh because those changes are huge, fundamental, and disruptive. So it's important to keep repeating what's going on in the automotive industry. Now, this overview shows a little bit more details in terms of, underlying numbers and trends like software and vehicles. It's going to grow by 9%. Sustainability, just before we started the webinar, Torben and I chatted about that. So it's going to be very, very important. Sustainability, automotive is a huge industry. So the industry is going with big steps towards higher sustainability. Agile development, I will have a session about that. I will not go deeper here, but obviously battery, electrification, it's a big thing. And as we all know, yeah, autonomous driving, the lower right box here, autonomous driving is very important because autonomous driving comes with a big technological challenge, yeah, to enable level 4, 5 in urban environments, a vehicle to drive in urban environments, a city. It's a huge, super complex challenge. Yeah. And this is linked to a couple of things, but very much linked to software. Yeah, this brings us actually to the next slide, which is shift towards software. Here are 3 voices from the industry. Christoph Grote from BMW, Ola Källenius from Mercedes, and we all know Linus Torvalds, the inventor of Linux. And, basically all 3 voices and the leaders here say software is going to be very, very important. Yeah. Bold statement from BMW, 95% of the innovation will be software. Yeah. It's important to understand and also control software to stay relevant, Ola Källenius. And obviously, I think a very important point from Linus, software is, it's not quite tangible, and a line of code or a software stack or components or an architecture, it's very often linked despite sophisticated processes, documentation, CM systems, but it's still very much linked to the people who have been written the software, yeah, who understand the architecture, understand the code, and so on, yeah. So, you know, the importance of humans, of human capital, yeah, I think that's really the point from Linus here, okay? Good, now let's move on. This picture I have gotten from Deloitte. They actually summarized very nicely what's going on with respect to the architecture, like the traditional architecture, you know, the electronic architectures in vehicles, kind of the presence, you know, like the traditional with many ECUs, very federal, very much distributed, kind of connected through a Kanban network, yeah. Then, you know, cross-domain, where you have, you know, certain, you know, let's say functionality domains, power, chassis, body, in-vehicle infotainment, yeah, but still very much heavily ECU inflated, I would call it, yeah. Then to the more current and future architecture, yeah, which kind of summarized by Deloitte here with centralized vehicle, you know, electronic architecture and vehicle cloud computing, yeah. And really, I would like to just summarize on the very right, like, you know, what's coming towards the end of this decade. It's a central computing platform with probably real-time Ethernet with some peripheral elements, mostly sensors, actuators, power elements, yeah. But the core architecture will be a multi-core, powerful computing architecture with multiple applications with different levels of safety and security on it. Yeah? So more or less separated with a separation kernel in order to separate applications, but a very strong, let's say, possibility to actually run powerful computing-intensive applications. What is also important here, what I want to share with you is we will see actually hardware architectures which are probably overpowered for the current software. So that means there will be application upgradability. Yeah, just one keyword, over the air updates. That means for the value chain and for the life cycle that actually over the life cycle of a vehicle, capabilities will be enabled through software. And this will also, as we can imagine, have an impact on the business models. Yeah, so there will be much higher and more significant revenue streams coming from software, either sold through subscription or, you know, through, let's say, pay by use, but it will be software enabled and the business models will change. Yeah, so all this is obviously leading to significant changes in terms of the architecture, the software, but also the business models and the ecosystem, obviously. This slide quickly here, I need to watch out for time a little bit, as indicated earlier. This is a very interesting slide I have taken from McKinsey. I really like the analysis from McKinsey. It was actually presented by an old fellow of mine, Georg Doll, in a meeting we had at this time at Intland. Yeah, and he's more or less explaining here, you know, what are the challenges in managing complex software. Yeah, and we're not going to go through all of them. I just want to pick two: version variety and interference of subsystems. Yeah, both will be very important for the future architecture, because when you have over-the-air updates, that means as a consequence, you are updating probably even the operating system, not only the applications of the vehicle. Yeah, and you need to know which version of a software with the full stack is actually running there. It also has an implication in terms of architecture, because you need to make sure that the hardware and the software are not as tightly coupled as they are coupled right now. And obviously, you know, point three, you can really only do this if you have a very clean, good architecture. That means clear separation in terms of modularity, clear interfaces, upgradability, and so on and so forth. Yeah. So this is something from an architecture point of view. When you look at your architecture and you more or less do requirements management for the architecture, you need to foresee what you want to do with the software stack and with the software assets. Yeah. Not only in a vehicle, you have multiple other use cases, like a computer tomograph, for example, yeah, or let's say a robot in the industrial industry, for example, yeah. So this is very, very important and relevant to consider. And again, overall, I like the analysis from McKinsey here in terms of what it means to manage complexity. Actually, one thought I also want to still share here. Yeah. Ideally, you are not just coming from the perspective, oh, I add more and more software, and more software is good, and more software is better. Yeah. In a design, you also need to review and look and say, are you able to actually reduce the number of lines of code by better reuse, for example? Yeah. Because you can imagine, more and more software sounds great, wow, yeah, but it also comes with a lot of challenges, yeah. So that means having also strategies for good reuse is extremely important because it has many benefits over the life cycle of the cyber physical system, yeah. This is a quick summary, also from McKinsey, yeah, in terms of, what are the challenges coming from waterfall to agile. And I will speak about it later on, how to manage, from classical distributed systems to central electronic architectures, as I illustrated it before. Yeah, obviously from start to production, how you manage the life cycle, with all the economics and the business models associated. Yeah, and obviously, from a few like, oh, we are building a complex system and it's engineering centric to a mentality which is really consumer centric, yeah, and user centric, which means really having in mind creating constantly user value, yeah, and obviously from engineering driven to data driven, yeah. Why is data driven important? The data driven element will have a high impact on both dimensions, on constantly improving the system, just one keyword, machine learning, autonomous driving, understanding failures, yeah, correcting failures, collecting data in order to improve the quality, the system, the experience, yeah, but also understanding better what the consumer, the user of the cyber physical system is doing, yeah, because this data on both dimensions has tremendous value, yeah. So you need to also think about, okay, what does it mean to collect this huge amount of data and how can you leverage, commercialize this data? And actually you need this data to actually stay competitive and to make fast, agile engineering decisions, but also business model decisions, product line management decisions. Yeah. Okay, so voila, let's continue. We have another 15 minutes. Yeah, some thoughts on systems engineering. Yeah, here you will see a few heavy elements also with PTC. I'm proud being part of the PTC family. It's a tremendous company with tremendous capabilities. And I'm convinced that actually PTC's approach to have a nice large portfolio of development tool assets, yeah, but also being open, I think that's the way to go. Yeah, you can choose a lot of tool technology. You have it here from CAD, ALM, PLM, IoT, augmented reality, supporting you on sustaining physical elements, yeah. But it's also a mix and match. Here you can go best of breed if you want, yeah. And this is what I like, yeah. And here is kind of the idea in terms of how to combine ALM with PLM, yeah. When we have been standalone at Entland, it was basically an ALM play with, yes, interfacing to PLM. Now we have with PTC a parent with very strong PLM capabilities, as we all know. Yeah, and obviously here the advantage is that you can have a systems engineering integration, change management integration, and product configuration. Yeah, even the importance of software will be more and more. Software will not run in isolation. Software will run always in a cyber physical system environment. Yeah, where it's combined with a very strong, multi-core ECU with sensors, with mechanical elements, and so on and so forth. Yeah, so that means, for achieving, for example, system traceability beyond the electronics, you need to have obviously the possibility to have this combination between ALM and PL elements. Yeah, which is obviously very important. Yeah. This here is kind of drilling down a short overview in terms of classical systems engineering, requirements management, modeling, variant management, source code management, classical, obviously DevOps, very important, agile, integration, test management, and simulation, co-simulation. Simulation, co-simulation will be very, very important. Why? Because simulation, co-simulation means more rapid innovation. When you simulate, you don't need the physical element. You can actually run cycles faster. Yeah, and those are the elements. So this is an illustration of some PTC assets, in order to actually cover those elements. Quite a busy slide, but still illustrating very nicely what is kind of in the value chest of PTC for you guys. Yeah, and obviously here CODEBEAMER prominently and on the upper left side, but obviously also Windchill and Vuforia for augmented reality, ThinkWorks for IoT, and so on and so forth. Yeah. And this V with this DevOps 8 symbol obviously illustrates, yes, the V model is still important, but you need to combine it with a very strong let's say focus on agile development, agile engineering, agile innovation. Yeah, with CI/CD elements, obviously. Yeah. This here is an interesting slide I have gotten from PROSTEP IVIP. Yeah, why actually this slide illustrates nicely. Today we have the challenge of kind of functional element blocks, very much kind of almost like divided by walls with different, let's say, data infrastructures and standards. Yeah, probably the standards. I think we are going to make a step forward if the standards, at least our standards, are not proprietary formats. Yeah, right now we have still very heavily proprietary formats. Yeah, in systems engineering. Yeah, and then you see on the very left side, it's cumbersome, it's complicated to really work in partnerships. Yeah, an OEM with a supplier. Yeah, it's symbolizing a lot of emails back and forth and convoluted, not traceable, and not with a clear process. Yeah. Tomorrow, what PROSTEP actually says is, digital data packages. Yeah, and the digital data packages more or less allow much better collaboration between the OEM and the supplier and all the ecosystem stakeholder. Yeah, and you have more or less, let's say, as is illustrated with these boxes, you have a box. Even there are multiple, let's say, standards combined because it goes to full digital thread, engineering thread across the full thread. It's much better manageable and the exchange and the communication is better. I'm personally absolutely convinced that those standards are extremely important. We in the industry need to drive those standards forward because those standards bring higher velocity, higher quality, higher, faster innovation, and obviously, interchange with less error, interchanging with less error proneness, and so on. Yeah, so it's essential, and therefore I thought I share this with you. You might know PROSTEP IVIP. I believe they're doing a fantastic job to actually drive standards forward. REC-IF is a very important one we all know in automotive. This slide here quickly, I need to watch out for time actually. This is just illustrating what I already indirectly shared before. When you are having a software-defined vehicle, where software is the center, the main brain of the vehicle, yeah, and you allow your customers to actually upgrade software, yeah, you eventually need and will have, and even before now you have that scenario, you will have components which are used to create features which are used to create, actually composed to create an architecture, and an architecture which will be actually deployed in multiple models. Yeah, this is a view from a tier one actually. Yeah, and this illustrates actually when this goes over the life cycle, you have multiple many complex permutations, and you need to have a tool chain which is allowing you to manage that. Yeah, with all the corresponding traceability. Because without traceability, you actually don't know which line of source code is linked to a certain, let's say, class, C++ class, to a certain component or subcomponent to a complete architecture. Yeah, it's actually non-trivial. It's anything else but not trivial. It's a big challenge. Yeah, and this here is just a quick run through in terms of what is our approach, PTC's approach with CodeBeamer. Yeah, you break it down in working sets, which are more or less, packages of functionality, which are clearly composed, yeah, and with clear interfaces, and which can be actually built together and composed with different asynchronous lifecycle. This is basically what you need, yeah, because when you do a release or you make changes, you're not always changing the complete system, you're changing subsystems, or you're just changing or kind of removing a defect, yeah. And this is obviously what you need in terms of infrastructure, yeah. This is just symbolizing here a product line management with agile development, kind of the V-cycle, vehicle, system, subsystem, component, with some logo illustrations of assets from PTC, but also from our partners. Yeah, I will not go into detail here because of timing. Yeah, now Agile 101, really 101 is kind of the elevator summary for agile development. Yeah, is waterfall approach still applicable? No. Why? You will probably miss key market windows if you continue going waterfall. Yeah, until you actually deliver value and get feedback from your users, like with MVPs, it's much too late with the classical waterfall approach. The waterfall approach is sequential. You need parallel, yeah, in order to meet market requirements, innovation requirements, quality requirements, time to market requirements. Only parallelism, yeah, is possible. Yeah, there is actually quite a few thoughts from industry leaders also there. Yeah, so key message here from my end is, hey, organize yourself agile and make sure your actually value creation is parallelized, because that gives you speed, yeah, and agility. This I spoke about this. This is this combination of the classical V model with the DevOps symbol, yeah, for all system levels. Again, because of time, I don't want to go into more detail. You all also know this. This is, I think, it's from Scaled Agile Framework. Yeah, what I want to say here is, it's not on the slide, but I say it verbally. Focus on value, value, value. Each agile team, they need to know, what's the value? Can we measure the value? Are we adding value? Yeah, and obviously you need to look what kind of agile team you have on different, let's say, architecture elements or even areas of the company. Yeah, keep always the linkage to the value. Yeah, and obviously delivering value, validating value, getting feedback, and then iterating in a fast manner. Yeah, and I can tell you guys, the iterations will get shorter and shorter and shorter. Yeah, just the market pressure in automotive and multiple actually forces, they are triggering that. Yeah, and they are actually accelerating that. Yeah, this just to sum up here is kind of a more sophisticated overview in terms of how this agility on the different system layers can be done. Yeah, the key message I want to share with you here is those kind of, they're not really circles, yeah, but these iterations, those iterations mean you need to have, let's say, the possibility to iterate, permanently improve with clear interfaces and traceabilities to the other layers. Yeah, but there needs to be, let's say, the possibility to do this kind of autonomous. Yeah, in order to allow certain areas of the overall architecture to actually develop further and to go through the life cycle. Yeah. Last but not least, a quick overview in terms of templates. Why templates? Templates are nothing else than a better starting point. Yeah, when you do, let's say, ASPICE, you have ASPICE requirements, or you need to adhere to certain standards, safety, security standards. Yeah, it's much better and obviously improves your agility if you're not starting from scratch. If you say, look, I have an ASPICE template or DO-178B for aerospace defense, yeah, and I can build on top of these standards my processes, the workflow, the whole organization of the agile rhythm, etc., etc. Yeah, and PTC is offering those templates, and they are coming with CODEBEAMER. Okay. Now, again, I'm really a little bit short. I need to speed up here. This is a quick overview in terms of business objectives, which are linked to some of the points I made earlier. Yeah, I will not repeat them. I will just show here. Look at the value. You know, are you constantly creating value, and is, let's say, your partner helping you to creating value? And obviously, what are the unique attributes here you need in order to make sure that this value is created? Yeah, obviously the value needs to be relevant for the end user, yeah, or different stakeholders in the engineering organization. Yeah, and this is kind of just a short summary for review for you. This is an overview in terms of, let's say, all the system elements and system engineering elements, but also beyond. Reuse is important. DevOps is important. Why automation? Configuration management is important. Yeah. Requirements management is important. So I don't want to leave out anything, but this is kind of for you a summary in terms of aspects you have to look out for your for reinventing also your organization and your innovation flow. Here a reference from Veoneer, how CODEBEAMER helped them to achieve some of the key points I was talking about before. Here's a reference from BMW. Because of time, we don't go into it. Here's a summary of some quotes from some customers. PTC with CODEBEAMER is working very closely together. And here are my final recommendations. Yeah, and these are the green ones are the important ones. Yeah, software architecture, look out for good architecture. Test automation, test-driven development. And you know this, but you know what? Quality doesn't come at the end. Quality comes at the beginning. It's linked to architecture. It's linked to good design. Yeah, strong modularity. Yeah, tools need to be embedded with good processes and with a good strategy. Without an innovation strategy, without an organizational change strategy, tools, yeah, it's secondary, but tools can be very important if they're embedded with a good strategy and a good process. CI/CD, I talked, yeah. Agile practices, really what I want to say, becoming agile is a big effort, yeah, and it needs to go through the whole organization. C-level executive support is key. Yeah, I have seen with very prominent OEMs where C-level people say we need to be faster, we need to become agile. Yeah, and that's important. Yeah, besides many other things, but I want to mention it. Cross-functional teams, and obviously culture at the end. You know, it all goes with people. Yeah, we are in the knowledge industry. Yeah, so that means culture of customer obsession. I like that. Yeah, because customer obsession is, you know what? All the stakeholders constantly think about, is this what we are doing creating value for our customers? Yeah, and how can we actually increase value? Yeah, and obviously linked to this is constantly driving forward, continuous improvement. I'm a fan about continuous improvement. You know what? You can make mistakes. You make maybe a mistake again, but you know what? When you're ready and obsessed about improving, then it's a high likelihood that you don't make the mistake a third time. Yeah, and obviously last but not least, employee value proposition. Yeah, invest in talent management, getting the best people, only with the, with good people, committed people. We are all good people, but we know what I mean. Yeah, focused people. It's actually possible to manage those challenges and to drive forward. Okay, good. So this is my summary. I am a little bit over time because formally we don't have time for questions anymore. Here is my bio overview with my coordinates, and I would like to check with you if you have still time for questions and you have some questions ready for me. Yeah. Happy to take them. Yeah.
Thank you, Andy, for the fantastic overview. And I think if you are still having a few people online here, we could just give it a shot for one question at least. Anyone who would like to raise your hand. I think we might have someone on the chat here. Let me see here. Right. I have one question here actually from one. What are the biggest challenges in transforming organizations to a more agile culture?
Yeah. So actually, I look at it from a let's say architecture point of view. Again, coming back to the architecture, the agile culture is it's when you look at it from like the tools perspective or web application, whatever. Agility you can achieve with a corresponding architecture, because you need a modern modular architecture in order to allow product increments based on unit tests with limited, let's say, system integration tests, and validation. And this is, I would say, also from our experience, this is one of the challenges. You can say, look, we go agile, but you need to also make sure that your architecture allows this agility. So there's one point I want to come up. There's one more point I want to share. It needs to be really lived. You can put some stuff, you can make courses, you can send people to a training, but when the agility aspect is fading out, with the processes, the sprints, obviously stand-ups and everything, measuring it, value creation, the whole organization needs to be really serious about it. Otherwise, it's going to happen, but not with the effect you want to really see for driving organizationally forward. Okay.
Thank you, Andy.
Yeah.
Time is unfortunately running out, so many thanks everyone for joining, and of course a special thanks to you, Andy, for sharing a lot of really exciting stuff here. So with that, I wish you all a fantastic weekend and hope to see you already back next week for a session on the future of work in the world of augmented reality by Accenture. So with that, have a fantastic weekend, everyone. Take care. See you.
Great. Thank you. Have a nice weekend.
Thank you.